Okay. A rational expression is an algebraic expression that can be expressed as the division of two or more polynomials. Now, before we go any further, I need to remind you of some stuff from grade 10 that I reminded you of in grade 11. You have seen this word before when we were talking about the number system, yes? What makes a number rational? Okay, if what repeats? The decimal. So I must need a division, yes? A rational number is x over y, right? What do we know about y? There's one thing it's not allowed to be. Negative. Y can be negative. It can't be 0. Y cannot equal 0. And if I do that division, the decimal must repeat or end, yes? But if we write anything in this form, it's automatically a rational number if x and y are integers, right? As long as x and y are numbers with no decimals and no other fractions in them, and y does not equal 0, we have a rational number, correct? Well, a rational expression is not the division of two or more integers, it's the division of two or more polynomials. What's a polynomial? I call your minds back to grade 10. A polynomial is, of course, any expression, and there is a more complicated definition than this, but for our purposes, this will suffice. Any expression containing variables and coefficients and constants. Now, it's a little more technical than that, as I have said. For example, this 1 over t squared is not a polynomial. But this is good enough for us, all right? Now, I'm going to write something over here in green. Negative 3 over 5. Is that a rational number?
Mm-hmm.
Why?
Because the bottom is not 0.
5 is not 0, and negative 3 and 5 are both integers, yes? Everybody understand that that's a rational number, correct? Now, I have a rational expression. Why? Because I don't know the value of this anymore, do I? Right? Because the numerator and the denominator are no longer guaranteed to be an integer, are they? So this part of the definition has to get thrown out the window. What about that part? That part I still need to keep. This, I have to worry about that part of it. That's why they're both highlighted in yellow. Is everybody cool? Mm-hmm. So let's take this, move it down here, and do some work with it. All right? A rational expression. X, it was minus 3. X minus 3 over x plus 5. We agree that that is rational right now, yes? Unless one thing happened. What is the only thing that could happen to that would make it irrational? If the denominator was 0, right, Burke? So this is rational, but it has what we call a restriction. And the restriction is just what Burke says. That restriction is no denominators in the whole expression can ever be 0. Everybody understand that? So in this case, the denominator can't be 0, right? So x plus 5 cannot equal 0. What do I do to isolate x there? I subtract 5, yes? If I subtract 5 from the left, what do I subtract from the right? 5. So x cannot equal -5. Does everybody understand that? X can be any other integer in the universe from -infinity to +infinity. X can be -4.999999999. X can be -5.000000000000001, but it cannot be -5. Does everyone understand that? No matter what, even if I put other stuff here, x can never be -5 because that would make that term irrational. Is everybody good? Okay. Those, whoa, slow down there, big stuff. Those are the rationals. Okay? If something is not rational, then it looks like this. These are some of the things that are not allowed. 4 to the x over x plus 5. That's not allowed. Okay? Because there can be no variable. Oops, I'm spelling variable wrong. No variable exponents. Which means if there can be no variable exponents, is this allowed for root x over x plus 5? Would that be allowed? Yes or no? I'm not allowed variable exponents, correct? Mm-hmm. Okay. So that's 4 to the x. But isn't this 4 times x to the 1/2? Mm-hmm. So should that be allowed? It's the exponent that I'm not allowed. Should that be allowed? It should be, but it's not. All right? I'm not allowed either variable exponents, and I'm not allowed radical variables. Now, why do you think that is? This one's easy, right? What if x was 7? Is there a square root of 7? No. Square root of 7 is irrational, correct? Which would make this whole thing irrational. What about this one? Why can't I have a variable exponent? Kind of the same reason. What if that exponent was 1/3? Then wouldn't that make that the cube root of 4? Does 4 have a cube root? That's irrational. Does everybody understand why these two rules are in place? Excellent. Okay, now, the restriction is that no denominators can equal 0. And we found that -5 would get us 0 there. -5, what color haven't I used on my highlighter? I haven't used green? Okay. X equals -5 is a non-permissible value. Okay? A non-permissible value is any value that not M, any value that fits into your restrictions. And a restriction is any time I can't exist. So the easiest one is denominators, but there's a couple more. One restriction is easy. Denoms cannot equal 0. Another restriction is any value that makes your expression irrational. So that was like the examples I was just giving up here, right? If x is 4, is this a rational expression? Yes, because square root of 4 is 2, 4 times 2 is 8, 4 plus 5 is 9, 8 over 9 is cool. Is everybody good? All right, prove it. What are my non-permissible values here? Where do I look to check my non-permissible values? There's no variable exponents. There's no radical variables. So I don't need to worry about those two. I only need to check where. Where is there a possibility in this expression to make it irrational? The denominator. And in this case, what about that denominator would make it irrational? If any of the variables equaled 0, I would be in trouble, wouldn't I? Right? So, how do I check it? I take my variable, or my denominator, 4 times s times r cannot equal 0, which means isolate them. R cannot equal 0 divided by 4s. What is 0 divided by anything? 0. So R cannot equal 0. S cannot equal 0 divided by 4R. So S cannot equal 0. Is there another variable here that might come into play? T is there, yes? What would happen? Can T mess us up in any way? That's what I'm trying to ask. T can be 0 because 0 divided. I have no pizza. Let's cut it up. How much do you get? Nothing. So T can be 0, but there's one other thing that could happen here and screw us up. Or is there? Can T mess us up? It's in the numerator. Can it mess us up? Take a guess. No? Well, let's try. We've already talked about 0, right? If T was any integer, is that okay? 5 times any integer gives us an integer, doesn't it? So we're okay there. What if T equaled S? Would that be okay? Then I would have 5t over 4t, because t and s were the same, r squared. Is that okay? I can't do t divided by t? It's 1, so that's okay too, right? What if t equaled r? Then I would have 4s over t squared. Can I do that?
Oh.
What would happen? 5 over 4st. Is that okay? So are we good? T can't hurt us, can it? So we've got our restrictions. R and S can't be 0. Then we would do any other work we could do here. Everybody cool? All right. What about this one? What can I do in B? What part do I care about? I care about the denominator. X times 2x minus 3 is not allowed to be what? 0. So now this is the question that almost all of you just got wrong on your last test. What does that should have been pink, what does that mean? What is happening there? X is multiplying by 2x minus 3. So, to make that 0, one of those would have to be 0, wouldn't they? So, either x would have to equal 0, or 2x minus 3 would have to equal 0. Neither one of those is allowed. Well, there's no work to do there. X is isolated, yes? So the first non-permissible value, NPV, is 0. I can't have 0 down there, can I? What about that one?
It's 3 over 2.
Right. 2x cannot equal 3. X cannot equal 3 over 2. Everybody understands why? Because if x is 3 over 2, what's 2 times 3 halves? That's 3. 3 minus 3 would be 0. 0 times 3 halves would be 0, and that's not allowed. Is everybody good? Okay. Now we go on to the hardest ones. What do I care about in C? P squared minus P minus 12. Now, we've already done that to death, haven't we? That's quadratics, isn't it? Where we're seeking the root, right? What would you do with that to find the roots? You, because you're from Brazil, will use the quadratic formula every time, right? Is there an easier way to do it? What? Factoring. Does that factor? Yes. To what? P minus 4, P plus 3, correct? And now we know that P minus 4 can't be 0, so P can't be 4. And we know P plus 3 can't be 0, so P can't be negative 3. Does everyone understand? Everyone's good? Now, if you use the quadratic formula, you're going to get negative 3 and 4, correct? For this to equal 0, which means those are your restrictions. The roots, if you quad formula, the roots are your NPVs. Does everyone understand? And just to prove it, let's work it through. 1 plus or minus the root of 1 minus 4 times 1 times negative 12. Right? Right? Which over 2, which is 1 plus or minus the root of negative 4 times negative 12 is positive 48, plus 1 is 49 over 2. What's the root of 49? 7 over 2. What's 1 plus 7? 8 over 2, which is 4. No 4 allowed. What's 1 minus 7? Negative 6 over 2, which is negative 3, not allowed. Is everybody good? Do I care if you quadratic formula every single denominator? No. But I'll give you a nice hint. I'm very nice to you. 99 times out of 100, your denominators will factor. But do you have to factor? No. Is everybody good? All right, turn the page over and let's see. But I really can't go on unless everybody's cool. Is everybody cool? All right, so simplifying rational expressions. What is a rational expression? You learned it 2 minutes ago. What is it? A division of two or more polynomials, yes? Which means they are what other word that makes you quiver and hide? They are fractions. So, if a bunch of rules exist for fractions, do those rules exist for everything else that is a fraction? Yes or no? Yes. Fractions are rational expressions. So that means all the rules for fractions apply here. All right? So, before we go on, if I wrote this in grade 4 and you were in Mrs. Bad Crumble's class, 6 over 4, would you hand that in? Of course you wouldn't. Why?
You need to simplify it.
You need to simplify it. How do we simplify it?
Multiply by 2.
No.
Divide by 2.
Divide by 2. What are we actually doing when we divide by 2? We are actually factoring, aren't we? Right? Because this is 3 times 2, correct? And what's the bottom? 2 times 2, correct?
Yeah.
What are we removing?
2.
2 divided by 2. We are removing a common factor, aren't we? When we get to the spot where there are no common factors, we can no longer simplify. Does everybody understand? Let me give you another example. 12 over 16. All of you automatically are going to divide that by 2. First thing you're going to do. Even though some of you already know this is 3/4, the first thing you're going to do, because I've been teaching for 20 years, is everybody divides by 2. Because it's an even number. So you're going to get 6 over 8, correct? They share a factor again, don't they? Because they both divide by 2. 3/4. Once I get to 3/4, the only factors of 3 are 3 and 1, and the only factors of 4 are 2 times 2 times 1, correct? What's the only common factor I can remove? 1, which is always removable. So, a rational expression is in simplest form. When a rational expression is in simplest form, the numerator and denominator no longer have any common factors. Does everybody understand? Everybody understands? So, let's work a bigger one together. 64 over 120. You all know how to simplify that. You're going to divide by 2, right? But what we're really doing is factoring. So, 64 is really 2 times 32 over 2 times 60, correct? Everyone agree? Right? So what am I going to do with that common factor? Cancel. Because 2 divided by 2 is 1. Now, that is really 2 times 16 over 2 times 30, isn't it? What am I going to do with the 2's? Cancel. That is really 2 times 8 over 2 times 15, isn't it? Cancel. Do 8 and 15 have any common factors? No. 8 is 2 times 2 times 2. 15 is 3 times 5. Anything common? No. So we're done. Everybody good? All right. So what does that tell us about rational expressions? If we're going to simplify a rational expression, we must do 2 steps. 1, factor when? Everything. Factor everything. And what was step 2? What did I do here and here? Cancel where possible. Now, so let's have a look at this first one. Notice the instructions. Read them to me. Simplify each rational expression. Be sure to identify non-permissible values. That means how much math do I have to do? I got to cover 2 things, don't I? Now, if I'm going to simplify, I got to factor everything, right? Once I have factored everything, then it makes it real easy to check for non-permissible values, yes? Because look what we just did. 2 minutes ago, we had a very yucky denominator. But once we factored it, it was really easy, yes? Okay, so when we're doing non-permissible values, sometimes we have to factor. And when we're simplifying, we have to factor. So if I got to factor for both them anyways, I might as well factor right now and then check for my non-permissible values, correct? All right, so what will I get out of the green section there? 3. And then what will be left over? X minus 2. Is everybody good with what I did there? And they both highlighted green. Yeah? Everybody's good? Okay. What about the pink one? What should I do there? I got to factor that, right? How do I factor that? You can't divide by 2 because that's a 1. Right. I need factors that multiply to what? Negative 20 and add to what? 1. What are they? Negative 4 and positive 5. So it is x minus 4. But it's not minus 4. What is it? 4 over 2. Because of that 2. And x plus 5. But it's not 5. It's 5 over 2. Simplify that. Over x minus 2. And where does that denominator go? Now, is everything factored? Once everything is factored, now we can check for non-permissible values. Where are they?
X minus 2.
NPVs. X minus 2 cannot equal 0. So what can x not equal? Can't equal 2. 2x plus 5 cannot equal 0. So x cannot equal negative 5 halves. Is everybody good there? Yes? Okay. Now, what's the last thing we have to do? We factored, we did non-permissible values. Now, how do I simplify?
The same one.
X minus 1, X minus 2. Cancel?
Cancel where you can. Is there any canceling to be done?
Yes.
Where?
X minus 2.
X minus 2 and x minus 2. Just like up here, 3 times 2, 2 times 2. I can cancel the 2's because I'm multiplying. Gone, gone. What is my final answer?
3 over 2x plus 5.
Done. Is everybody good? Yeah? Okay, let's look at the next one. Factor first. What is there something I factor out of the numerator that would make my life easier? Something about the way the numerator is written bothers us. What? None of you are bothered by the way that is written.
Oh, you can change it.
I would change that to what?
2 minus
I would make that -1 t minus 1. Right? Because -1 times t is negative t. -1 times -1 is positive 1. Why am I doing that? Because this is how we like to write our polynomials, yes? We like the letters first. So if you can do that, go ahead and do it. It's just factoring, right? Because -1 can be removed from everything. Over. How do I factor the bottom one? Is that a perfect square? Sure it is. We can factor that in our sleep. T plus 1, t minus 1. Now that it's all factored, here is where I do my NPVs. What are they? T plus 1 can't equal 0. T minus 1 can't equal 0. So t can't equal what? Plus or minus 1. Right? Everyone's good? So I'm over here. Now I come back to here and cancel. Is there any canceling I can do? T minus 1 and, excuse me, t minus 1, yes? Cancel, cancel. What's left? -1 over t plus 1. Can everybody do it? Yes? All right. You try C. Step 1 is what? Factor, factor, factor. Where? Every single place you possibly can. Go. We've already done the first one, of course. Oops. Plus 1. Minus 2. All of you should be able to get to there comfortably. Once it's factored, then it's NPV time. So y plus 5 cannot equal 0, so y cannot equal -5. Y minus 2 cannot equal 0, so y cannot equal 2. Then I go back and cancel. Where are my cancels?
y minus 2.
And y minus 2, leaving us with what?
2y plus 5 over y plus 5.
Now, all of you are going to make the next mistake at least once. You are all going to tell me that the y plus 5s can cancel.
No.
They cannot. Okay? They can't. If y was 1, then this would be 6 on the bottom, wouldn't it? And 2 times 1 is 2, plus 5 would be 7 on the top, yes? So if y equaled 1, then this answer would be 7/6 if y equaled 1, correct? If I cancel, then 2. Is 7/6 2? No. So you have to be careful. You will all want to do that. The other time you will want to do that is this case. X plus 5 over x. You will want to do that. That is not allowed because of what I just showed you. If x was 1, this answer would be 6, wouldn't it? But if I cancel x's, the answer is 5. 5 does not equal 6. Does everyone understand? The other one you will try and do is this move, x minus 3. You will try to cancel the x's. Why? Same thing on top, same thing on the bottom, Mr. Myers. Because you've been taught that trick. You haven't spent enough time learning what this means. You can only cancel when you are multiplying. Aight? X times 5 over x times 3, that you can cancel. Because they are a shared factor. Does everyone understand? Okay, you guys do the next one. Remember, just to help you out, 1 factor, 2 NPVs, 3 cancels. What's wrong with the green one that we don't like? I don't like the order it's written in, yes? So, do 2 and 6 share a common factor?
Yeah.
What is it?
2.
So you're going to bring out a 2, right? But you don't like the negative 2 in there, so you're going to bring out a negative 2. So the top becomes negative 2 m minus 3. Does everybody understand what we did there and why we did it? Okay. And what's the bottom?
N minus 3 and n plus 3.
It's the difference of squares, so it's m minus 3, m plus 3. Have I factored?
Yes.
So let's NPV it. M cannot equal what? Plus or minus 3. You should be starting to see this immediately, right? You should be getting yourself away from this. And step 3, I mean, is cancel. What cancels? Minus 3, minus 3. And I get negative 2 over m plus 3. Is everybody cool?
Can you do that as well if you want a negative 2?
Pardon me?
Can you do it as well if it's like not negative 2?
If you didn't take out a negative?
Yeah.
Well, then this is not m minus 3, it's 3 minus m. That's different, right? So you can't. You have to get that negative out of there. And let me show you why. Once again, you don't need to write this down, but I want you to see it. Let's pretend m equals 1, right? What is 1 minus 3? What's negative 2 times negative 2? Negative 4, right? No, positive 4, right? Negative 2 times negative 2 is positive 4, correct? And what is m minus 3 is negative 2. M plus 3 is what? 4. Negative 2 times 4 is negative 8, which would be negative 1/2, correct? Agreed? Now look at the simplified version. M is 1. What's 1 plus 3? Which is negative 2 over 4, which is negative 1/2. Same thing. That's why we can cancel. Is everybody good? All right. Now, remember, Friday, next test. Tonight, I want you to try tonight you're off the hook. No. I lie. Because you have the answers here. Tonight, you're going to do just page 124. Yes. Yes, I want the tests back. Did you write your review score on them? Everyone but Ayaka.
I did.
Yay! Bring your calculator back, take your phones. Class is over in like 1 minute. Or your fancy watch. Over there. There we go. Ugh. Diwali's not a single day, is it? I thought it was like a range of days. You're not sure. Okay.
みさんっていう正確なのかな。ちのちゃん分かったかい
I would actually give it this one. And then this 0.5.
Yeah. Oh, I didn't see the. Okay. Yeah, you can have another half mark.
Yeah, and this one. I didn't understand what was wrong about it. I got the two roots. Then use the edge for the vertex. And then I just.
I maybe didn't see that. Don't know. Maybe I only saw that. I don't know. So you can have another one mark. So I owe you 1.5. That's why I go over them.
Hi, Mr. Lyman.
Are you giving it back to me, or?
Yeah.
Oh, okay.
For Fridays, are we like doing everything like this and a graph?
Yeah. With B-A, that's C. I'll be here.